Hey guys, this will be just kind of a step up as we travel through this whole atomic structure unit. We're going to do something else. I'm going to blow up this particular square, the square with beryllium in it, and make it kind of visible. And this should be reviewed by now. You know that this is the atomic symbol for beryllium. You know that this is the atomic number, which is the number of protons and electrons. You can probably figure out that by this time that this means most of the time there are 5 neutrons in the nucleus of a beryllium atom. And man, if we were to have to bother to draw it all the time, it would be such a pain. But we're going to learn how to make it so that we don't have to draw it all the time. So there's my 4 neutrons I'm putting in the nucleus because of the atomic number 4. And I'll make 4. Those were 4 protons, positively charged subatomic particles. Here's my 5 neutrons, excuse me. Okay, so there's my nucleus. And we also know, just because we've gone this far and we've learned that there's going to be 2 electrons on the innermost shell here, and that's how many electrons can fit in that shell. And we know that really it's not just an orbit, but it's just like a ball of electrons flying around. And then on our outermost shell, that just leaves 2 more because the atomic number is 4, and there we go. So we have a beryllium atom. Now, what I'm going to show you next is sort of, let's not have to do that every time, okay? Beryllium's in group 2, which means it has 2 electrons. Things that are in group 2 in the periodic table, this right here is group 2. And things that are in group 2 on the periodic table have 2 electrons on their outermost shell. And they're pretty unstable. They're often used in things like fireworks. And in a little bit, I'll show you a video of me lighting magnesium on fire. It's also in group 2. Anyway, this is what we do to symbolize those 2 electrons in the outermost shell. We take those 2 electrons and we go 1, 2. That's what's called an electron dot model. That way, we don't always have to bother to draw the atom over and over and over and over and over again. What a pain in the hiney that would be. We can just draw the electron dot model. Let's take carbon. Carbon's nickname is God's glue because carbon really attaches to a lot of different things to create organic life. Carbon's a big deal in nature. All of the foods that you eat contain carbon, and most of you is made of carbon, hydrogen, nitrogen. Carbon's a big deal. Carbohydrate, like when you eat a potato, that comes from carbon. Okay, so it's atomic number 6, and if we had to bother to draw the atom, we would draw 6 protons. And trying to get to the point where we don't have to bother to draw it, but there's 6 protons, 6 positively charged protons there in the nucleus, and 12 minus 6, that means 6 neutrons, right? The atomic mass minus the atomic number is 6 neutrons. I think I drew 6 in there. And then now the most important part, this what we want to focus on is this outer shell. Now it's in group 14. 14 should give you a clue of how many electrons are in the outermost shell. There's the 2 that fill up that inside shell. 6 minus 2, that leaves 4 more. And it's in group 14. Things that are in group 14, 4 on the outermost shell. Okay, so how would we make the electron dot model for carbon? We'd go like that. We'd go 1, 2, 3. Notice I'm going clockwise. 4. Okay, So that's our carbon. So we're getting pretty good at this. Things that are in group 14 have 4 electrons in the outermost shell. Notice I'm skipping these guys. These are what's called the transition metals. And I'll go. Things that are in group 1 have 1 electron. Things that are in group 2 have 2 electrons in the outermost shell. Then I skip the transition metals and I say things that are in group 13 have 3 electrons in the outermost shell, 4 electrons, 5 electrons in the outermost shell, 6 electrons in the outermost shell, 7 electrons in the outermost shell. And these guys are full. We'll get to that in just a second. But I skipped the transition metals, and the reason is that they're a little bit tricky and unpredictable. We'll get to that when we do our next unit. That's a little more complicated than I want to get into right now. Okay, I want to talk about the rule of octet. And in order to talk about the rule of octet, I need to draw an electron dot model for neon. First, we got to figure neon out. So I've got my neon that I'm going to blow up here. And I've got my number 10, my atomic number 10, so we know it's got 10 protons, and most of the time it looks like it's going to have 10 neutrons. Okay, so now I'll still, for a little bit, just to kind of baby us along, I'll still go to the trouble to draw the atom, and it's fun also. Okay, so I'm going to go 1 proton, 2, 3, 4, 5, 6, 7, 8, 9, 10. You notice I don't want to do this with some of those atoms that are way down there at the bottom of the periodic table, you know, like uranium and stuff. It would take me all day. And 20 minus 10, that gives me 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 neutrons. Okay, now, just like always, that first inside shell fills up with 2 electrons. Okay. And what does 10 minus 2 equal? It equals 8. 1. No more room in the end. 2, 3, 4, 5, 6, 7, 8. Boy, I'm glad that I can do an electron dot model so I don't have to bother to draw an atom all the time. Okay, so neon's electron dot model, let's do 8 electrons to symbolize that, is 1, oops, let me get it up here where we can see it. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the rule of octet states that this is full. We've reached 8. It's full. Everything in group 18 has a full outer valence shell, absolutely full. So it's referred to as the noble gases. Okay, the noble gases do not bond in nature with anything else because they're absolutely full. If you take carbon, for example, back to carbon, you could attach, hydrogen to carbon to make CH4. You could do that, but neon is full. It's got 8 electrons in its outermost shell. It's full. Same with argon. Same with xenon. These guys are all full. They're the noble gases, and they don't bond with anything. So that's why you can see why, neon is something that's found alone in nature by itself. You don't find neon bonded to anything. Hydrogen, you find bonded all the time to stuff. Lithium, if you look at lithium, which is in group 1, man, it's going to bond all the time with stuff because it needs to fill this outer shell with 8. 1, 2, 3, 4, 5, 6, 7, 8. And it's unstable. So it's always going to bond with stuff in nature. Now, if you look at things that are in group 17, for example, fluorine, a fluorine atom's in group 17. Group 17 means 1, 2, 3, 4, 5, 6, and 7. It means it's got one electron that it needs to fill that outer shell. So it would bond with something like lithium really easy. That electron would go over and fill that to make lithium fluoride. Okay? And we'll get into that next unit. But that's the important thing. The reason these electron dot models are so important is they give you an idea of what the outermost shell looks like in an atom. Things that are in group 1. Things that are in group 2. Things that are in group 13. Things that are in group 14. Things that are in group 15. Nitrogen. Things that are in group 16. Things that are in group 17. And then things that are in group 18. This is the one that Superman was vulnerable to, Krypton. Anyway, he was kryptonite. But yeah, that's kind of electron dot models and how you travel through it. So let me finish with a mini quiz for you. Please draw an electron dot model for iodine. Please draw an electron dot model for calcium. And please draw an electron dot model for cesium. Take a minute and do that. I'm going to give you the answer in just a second. Look at a periodic table. You can always Google periodic table and click on images, or you can pull up the one that's provided for you online. Or let me give you a periodic table. Okay, so here's a periodic table of elements, and I'd like you to try to draw those three. Okay, I'll give you the answer in about 1 minute. I'd like you to draw it before I give you the answer. Okay? You've got about 45 seconds. You know you're learning this stuff if you can beat me to the answer. I'm going to give you the answer, so getting the answer is no big deal. But can you do it before I give you the answer? That's the challenge. That's how you know you're learning. So you've got about 30 seconds. Okay guys, let's do this. So iodine is found in group 17. So if you weren't able to get the electron dot model for it, I just gave you the big clue. So hopefully you can beat me to it. Things that are in group 17, their electron dot model looks like this. 1, 2, 3, 4, 5, 6, 7. That's iodine. Okay, calcium is in group 2. See if you can beat me to it. Calcium's in group 2. 1, 2. I don't really care where your dots are. I just want you to make sure that you have 2 of them. And cesium right here is in group 1. Okay, so be ready to be able to do that on a test.